This question asks us to determine the acceleration of this object when it's subject to three forces. We have a gravity force of 40 newtons, and remember that's going to be mg. So you should already make a note. I can know the mass, since we're assuming g is going to be about 10 newtons per kilogram. What the heck? Let's already do it. We know the mass is 4 kilograms. Okay. And of course, not of course, but we see that the normal force is going to equal the gravity force. So that tells us we basically just have something like a block, and there's nothing else pressing down on it. But we also have this friction force. And you'll see on your equation sheet is friction force equals the coefficient of friction times the normal force. And it says that it's sliding, so this is actually kinetic friction, although that really is not an issue in this problem. And we say, what is the acceleration? Okay, so we know that acceleration equals the sum of all the forces, and we're particularly thinking about the x direction of our frame of reference. So this is all about the x, and of course the only force we have is the friction force, and that's in the x direction, and so that's going to be divided by the mass. So this is Newton's second law. Okay, now we're going to think about going back over here. We're going to say, okay, well, what is the friction force? Well, we already, from our work earlier this year, we know that, and we see it right here, that the normal force is equal to the gravity force. So this is just going to be mg. Now I already know that that's 40 newtons, but I'm not going to put the numbers in yet because I think something's going to cancel. So we're going to replace the friction force with that value, and we're going to put it over m, and my instincts were pretty good here because I see that it cancels. So we didn't actually need to know the mass of the object. And we see that the acceleration rather is going to be simply the coefficient of friction times little g. And so we have 0.2 times 10, so the acceleration is going to be 2 meters per second squared. So I look at my answers and I see, oh, okay, well, which way? Well, hopefully one of the key things we learned is that forces cause acceleration. So if the force is to the left, the acceleration is going to be to the left. We don't know whether this is speeding up or slowing down, but we know the acceleration is to the left. So 3 is B. Question mark number 6. And the reason these are out of order is because they just come from many different sources. Okay, this one is definitely a little bit more complicated. Some of the questions on the exam are going to be easy, some are going to be medium, and some are going to be really challenging. Or just challenging. Okay, so here we have block B and block A are connected by a light string that passes over a light pulley, which means forget about the mass, forget about the fact that the pulley is even there, except that it's going to bend gravity. It's going to turn a downward gravity force into a sideways pulling force. And we're told that the students are going to basically, where the heck is it? Okay. So the students want to determine the mass of block B from simply the motion of the two-block system after it's released. They plan to measure the time block A takes to reach the floor. So you can assume they already have a means to measure T, the time it takes for block A to reach the floor. What else do they need to know to get the mass of block B? Okay, well, let's think about it. These things are going to accelerate as a system, so, and we've talked about this, is that a little bit, and this is frictionless, which makes it nice, is that if we think of our block B and A together as a system, basically the force that's going to cause everything to start to accelerate, the block B will go this way and A will go this way, but the acceleration of the whole thing is basically going to be just some value A. And that's going to be caused by the force that's making this thing move, which is the gravity force on block A. So that's going to be the weight of A, which is the mass of A times little g. And here's the key point, is to recognize that both the mass of block B and the mass of block A are together count towards the total inertia of this system as it accelerates due to the gravity force just on A. So this is going to be the mass of A plus the mass of B. And so this is one of the this is probably the biggest challenge. Coming up with this, because then you can see, okay, what do I need to know to get the mass of B? I already know little g, and to solve for A. So basically I have to get to the point where I can know everything in this relationship except for B, mass of B. Well, I know little g, so it looks like I'm definitely going to have to know the mass of A. And I'm also going to have to know the acceleration of the system. So let's see, I can already go down. Let's do a first pass of the answers. Only the mass of block A. Well, I need to know the acceleration of the system, so I don't think it's going to be A. Only the distance block. Okay, well, I guess I'm not really ready yet to start eliminating. Okay, how am I going to get the acceleration of the system? It's going to start from rest, and it's going to fall some distance. Are they calling it? Let's just call it delta x, since we often call things distance delta x. It's going to follow that. How can I get acceleration? If I know the time, and I know the distance, and I know it starts from rest, then we have this equation that says displacement equals initial velocity times t plus 1/2 at squared. And of course, it starts from rest. So this is the relationship that will tell us acceleration. Okay, so what do we need to know? They've already determined they need to get time, and the question is, what else do they need? Well, we can't know acceleration. Even if we have the time, we can know the acceleration, but we have to also know the distance that it's going to fall. So what do we need to know? We need to know how far this block A is going to fall. They've already got the time. We're going to need to know the mass of A. And that's it, because this will tell us the acceleration, and that's dependent on time, which is already measured, and we need to know the distance, and we need to know the mass of A, because if we know all that, we can then solve for the mass of B. So which one says we need to know distance and mass of A? No. Mass of A and the distance it falls. Check. Let's just confirm. Yes. Okay, the radius of the pulley. It's a lightweight pulley. The mass is negligible. So the correct answer for 6 is C.